This movie is on circles in the coordinate plane. This goes with learning target 12. Our warm-up question: the owners of an outdoor adventure course want a way to communicate to all points on the course. They are considering purchasing walkie-talkies with a range of a half mile. A model of the course is at the right. Each grid unit represents 1/8 of a mile. The base station is at 2-4. Do you think the owners should buy the walkie-talkies and why? So if each grid mark represents 1/8 of a mile, and we know our walkie-talkies reach up to a half-mile radius, let's start at the base station and let's go 1/8 of a mile, 1/4, and then 2 more will bring us to 1/2 mile. So that's going to represent my radius for the circle that I'll create around the base station. So I extend out to that radius and I see if the rock climbing, the tire course, the ropes course, and the mud pit are all within that radius. Because if they are, the walkie-talkies will work. So it looks as though they should buy the walkie-talkies because they all are within that radius. So that's what we're looking at in this lesson. Circles on the coordinate plane, and we're going to add equations to those circles. The information in the equation of a circle allows you to graph the circle. Also, you can write the equation of a circle if you know its radius and its center. So I want you to take out your blue sheets, pause this movie, and add our equation for the circle here. Add that to your blue sheet, given that you have a center at HK and a radius of R. And then press play when you're finished adding this to your blue sheet. The notes for this unit are also available in your guided notes packet for this unit. It's at the end. Okay, now that you've added this equation, looking at this equation, I want you to realize that we have an x and a y in this equation. And the x and the y are there because we have an equation just like we would a linear equation would have an x and a y. A quadratic would have an x and a y. A circle equation also has an x and a y. This equation stems exactly from the distance formula, and we're going to see that in a second. But the h and the k, these numbers are representing the center of our circle, and then this is our radius, r. Here's an example of the distance formula using this circle, and if I plug in hk here and here for my x1 and y1, and I plug in radius, because that's what we're trying to find, not the distance here, but just the radius of the circle, then I solve this equation by squaring both sides, and I end up with my standard form for the equation of a circle. So this equation that we have actually stems from the distance formula. So I put it up here. We're going to write an equation of a circle, standard form, with a center at 5, -2, and a radius of 7. When we have a center of 5, -2, we have that 5 is going to represent our h, so that's our x-coordinate, and 2 is going to represent the k. So we have 5, -2 is the center of our equation, or circle. The radius is 7. So if 5 is my h value and -2 is my k value, I can take that and plug it into this equation where I plug in -5 or 5 for h and I plug in -2 for k. So y minus k becomes y minus a -2. And I simplify this and I get the quantity x minus 5 squared plus y minus a -2 is y plus 2 quantity squared equals 49. The reason it equals 49 is because my radius is given as 7. 7 squared is 49. And that's how you get your equation. It's that simple, just plugging it in to your circle standard form equation. where you've got your h, your k, and your radius squared. Let's do these two. Pause the movie, try these on your own, and then press play when you're ready. Okay, now that you've tried both of these, let's look at this. In this problem, we're going to look at h is 3, and our k is 5. Our radius is 6. So in our equation here, we plug in 3 for h, right here. We plug in 5 for k, right here. And we plug in 6 for r. And when we solve that, we'll get x minus 3 squared plus y minus 5 squared equals 36. 36 because we had to square the 6. Yes, it is that easy. If you're doing this one, that's your h, that's your k, and this is your square root. When you plug it in here, your h value, excuse me, h is going to be negative 2. So when you subtract a negative 2, what happens? It's the same as adding, so you get a positive 2. K is negative 1, so when you subtract a negative 1, then you get positive 1. So x plus 2 squared plus y plus 1 squared gives us, now the square root of 2 squared, when you take the square root of 2 and you square it, you get 2. It gets rid of the square root. So that's why we get 2 here. So check yourself, see how you did, and press play when you're, or pause to correct your mistakes, and then press play when you're finished. All right, let's go to the next one. What is the standard equation of a circle with the center at 1, negative 3 and passes through 2, 2? So here we have the center. Here's where it goes through. If I connect these with the line segment, that's going to be my radius. And what I can do is I can create a right triangle here to do Pythagorean theorem to get what that radius is. So I get a distance of 1 right here. And then I have 1, 2, 3, 4, 5. So I do 5 squared plus 1 squared equals 26. So my radius is square root of 26. My radius is square root of 26. And that stems from the distance formula, or from the Pythagorean theorem over here. 5 squared plus 1 squared equals x squared. So we get square root of 26. Don't simplify that because in our formula we want to square the radius, and the square of a square root gets rid of it, and we get 26. So when we plug this back into our formula, this is going to be our h, and this is going to be our k, and square root of 26 is our radius. So I get x minus 1 squared plus y minus a negative 3, which what is minus a negative 3? What does that become? Positive 3. And the square root of 26 squared becomes 26. So we get x minus 1 squared plus y plus 3 squared equals 26. What is the standard equation with the circle 4, 3 that passes through this point? Pause the movie and then press play when you are finished. Okay, if you've not really tried this problem, please pause the movie and try it, because I'm going to go over it and I want to make sure that you've tried it. We have a center of 4, 3, so that's our h and our k. 4, 3, 1, 2, 3, 4, 1, 2, 3. That's the center of our circle. It goes through point negative 1, 1, negative 1, 1. So I know it goes through that point. If I connect it with a line, I could make a right triangle and do Pythagorean theorem, which would give me 2 squared this is 2 right here. And this would be 5. So 5 squared plus 2 squared is 25 plus 4, 29. So I get the square root of 29 is my radius. And then I plug in my h and my k. And I should get x minus 4 squared plus y minus 3 squared equals 29. Because you square the radius, so square root of 29 will become 29. If you know the standard equation of a circle, you can describe the circle by naming its center and radius. So let's try that. When you make a call on a cell phone, a tower receives and transmits the call. A way to monitor the range of a cell tower system is to use equations of circles. Suppose this equation here represents the position and the transmission range of a cell tower. What is the graph that shows the position and the range of this tower? So we've got this equation. Let's see if we can extract out what our h and k would represent here. H and k being the center of our circle. It's an h and then a k. And then the r representing the radius of our circle. So here, I know in my equation I need y minus 2, but I have y plus 2, so it must be y minus a negative 2. This guy's fine because x minus 7, x minus h is my equation. So I know h is 7, but over here, k must be a negative 2. Now 64, if I think what the square root of 64 is, I know that 64 is 8 squared, so that's going to be 8. So our center is at 7, negative 2, and the radius is 8. To graph that, we can plot that point. We can draw our radius or use our radius with a compass and then create the circle. What is the center and the radius of the circle with this equation? Graph the circle. Instead of graphing, let's just find the center and the radius. Pause the movie and press play when you're finished. Okay, you can obviously tell that I can't draw on here. We need the center and we need the radius. These are the two things that we need to extract. So you can see in our equation x minus h. So that means that 3 must be h. And here I've got y minus k, but I have y plus 2. So this must actually be y minus a negative 2. That way, I can identify my k, which would be a negative 2. So my center is located at 3, negative 2, and my radius is square root of 36. And that is 6, because square root of 36 is 6. And you can graph it, seen here, 3, negative 2, radius is 6. That's all for this movie. You've now completed Learning Target 12. You may start your homework.